Hello boys and girls, it's Mr. Giomini again, talking about scientific notation. A couple things I want to remember about scientific notation. Whenever I'm doing scientific notation, I'm doing it something times a power of 10. So something to the power of 10. So I'm going to have an exponent up here. We don't know what the exponent is. It's going to either be positive or negative, but the base is always going to be 10. And this number here, it's important. This number here, we'll call it n for now. It's going to be greater than or equal to 1, but that number also has to be less than 10. So if I go over here, it says express this number in scientific notation. So right now I know I'm multiplying something by a power of 10. I'm going to have some exponent and some number here that must be greater than or equal to 1, but less than 10. So if I take this number, here's the decimal point. I want to move that decimal point inside here, because those are the digits where finally it becomes something other than 0, so that the number is greater than or equal to 1, but less than 10. So I'm going to focus on the digits 5, 0, 7, 7. Now, looking at those, where can I put a decimal point at so that the number is greater or equal to 1, but less than 10? Well, let's say I put it here. Well, this number here is 507 and 7/10. Well, that's greater than 10. My number must be less than 10, so I can't do that. If I put it here, well, that gives me 50 and 7700. So that's still greater than 10. It must be less than 10. So, hey, look, it has to be here. So in my value here, it's going to be 5 and 77 thousandths, because I'm going to put all the digits until it ends with a number that's other than 0 there. Unless I have other digits here, but so right there, so I have 5 and 77 hundredths. Now, going back to the original problem, okay, going from this 5 and 77 thousandths to this, oops, let me go back on pen. Question is, did I get bigger or smaller? So this is $5. This is obviously, there's nothing in the ones place, so that has to be less than $5. So that's why it's going to be a negative exponent. Now, let's take a look. From here to here, how many places did I move the decimal point? 1, 2, 3, and 4. I moved it 4 places to the left. We get that negative exponent. Now, we should remember that 10 to the negative 4th, again, is not a negative number. It's really, let's see, 10 to the negative 1st was 1/10. 10 to the negative 2nd was 100th. 10 to the negative 3rd was a 1,000th. And 10 to the negative 4th is 1/10,000. So really what this is saying, I'm multiplying 5 and 77 thousandths times 1,000th, and I'll get 10th, 100,000, 10,000, 100,000, million, 10 million. 5,077 10 millionths. So if I go to plug this answer in, it becomes 5 and 77 thousandths times 10 to the negative 4th power. Let's take a look, see if I have it right. Hey, all right, good. Okay, this one, a little different. I have it in scientific notation now. I want to convert it to standard notation. So we have 5 and 824 thousandths times 10 to the negative 2nd. Now I think of negative 2nd, I know it's not a negative number. This really means it's going to be less than 1 but greater than 0. So let's see here. Negative 2nd. Well, if I had a 1 here, that'd be the negative 1st or 1/10. So it must be, we're timesing this number by 100th. So that means this number is actually going to get smaller because I'm multiplying it by a value less than 1. If I multiplied it by 1, it would stay the same. But because I'm multiplying it by less than 1, it's going to get smaller. And so really I'm dividing this by 100th. So I'm going to move that decimal place. Look at the exponent. It's a negative 2. So it says, hey Scott, move the decimal place 2 places, and because it's a negative, it's not going to get bigger, it's going to get smaller. So instead of multiplying by a power of 10, I'm really dividing by 100th. So I move over 1 decimal place and 2. That means the decimal place will be here. In this void, this empty spot, will go as 0. Now again, I like to put a 0 to hold the place value of the ones place. Decimal point 05824. Let me double check that. 05824. Check my answer. Hey, I have a smiley face. That means I'm smiling. Next one, same thing. I'm taking the scientific notation and converting it to standard. I'm going to rewrite it down here. 4 and 421 thousandths times 10 to the negative 3rd. Now 10 to the negative 3rd is also equal to, let's see here, It's less than 1 but greater than 0. So there's a 3 here, so we have 3 values after the decimal point: tenth, hundredth, and thousandth. So I'm really multiplying 4 and 421 thousandths times 1,000th. Now if I were multiplying it by 1, it would stay the same. I am multiplying it by less than 1, so that means this decimal is going to move to the left. And the exponent tells me how many places to the left it'll move. It'll move 3, so I need to move it 1 and then 2 more places. So I'll put in 2 voids there, 2 empty spots. I'll put my decimal there. I'll just plop 2 zeros here. So really that's moving 1, 2, and 3. Exactly what the exponent tells me to do. So my new number will be 0.004421. Let's take a look. Alright, let's try 2 more. Okay, converting this scientific notation into standard. I'm going to come over here. Let's change colors. Purple. It's a nice color. Makes me happy. 3 and 643 thousandths times 10 to the negative first. Okay, I remember negative first is the same as 1/10. Okay, so if I were to multiply this by 1/10, now I could do it the long way and go like this. That's 3, that is 4, that is 6, that is 3. There's 3 decimal places here, 1, 2, 3. There's 1 decimal place here, 1, so I can move it all together 4. The decimal point really is here. It goes 1, 2, 3, and 4. Plop a 0 here. Or I could also, again, the way to look at this, I want to show you how to use it using multiplication. Now we could say, hey, or really, it's to the negative first, meaning this number is really getting smaller. And I'll move that decimal 1 place to the left. Plop 0. Look at that. See how those numbers are both the same? So you can actually multiply these out the long way using this multiplication algorithm, or you could just kind of figure out the decimal point, or that using that power of 10, that exponent, whether it's positive or negative, to help me tell me which direction to move my decimal point. So we have 0 and 3,643. Is that 10 thousandths? All right, last one. Oh boy, I'm glad this came. Express this number in scientific notation. Now remember what I said. When we talk about writing it, converting it to scientific notation, we're multiplying some number by a power of 10. And I need to have an exponent up there. I need to have some number here. Now remember the key to this number. This number must be greater than or equal to 1. So it can be 1. But that number also must be less than 10. So looking at this number, I'm going to focus on these digits right here, because these are the number, they don't have zeros. We're focusing on, so really I'm focusing on 1177. Now where can I place a decimal point where the number will be greater than or equal to 1 but less than 10? Again, if I were to put it here, this would be 117. That is far greater than 10. It cannot be greater than 10. Okay, so I'm going to have to take rid of that, get rid of that little decimal point. Can't be there. Oh, put that 0 back. That 7 back. Okay, I'm thinking, wait a minute, I can only put it there because that says 1. I have a 1 in the ones place followed by 177 thousandths. That is greater than 1 but less than 10. So 1 and 177 thousandths times 10 to the. Now, I am taking this number and turning it into this number. You have essentially $1.17. Here you have $11 billion. $11,777,000,000. So did I get bigger or smaller? Well, I got bigger. So that means this is going to be a positive exponent. Now, the decimal point in this number really is here. I'm going to move it all the way to, let me get rid of some of these notations here, all the way to here. So if you want to think about it, let's see how many places it moved. I can count by 3s here. 3, 6, 9, and 1 more, so that is now 10 spots. So this would be 1 and 177 thousandths times 10 to the, what did we say here again? 3, 6, 9, 10th power. All right. Hope this helps you out with scientific notation. Have a great day.